Okay, so welcome to the first event of LLMOps.Space. LLMOps.Space will give a bit more about the community, but basically I'll say we're focused a lot around the Discord, and we're also going to have this type of events. We don't know the frequency yet. We don't know the topics yet. We're kind of figuring out everything as we go, because as you can see here, it's webinar number 1. But I'm really honored to have Rafael and Puneet here. We'll give a bit of background. And what we're going to be talking here is about building an LLMOps stack for large language models. So this is going to cover a couple of different things, and we'll talk about all of them kind of as we move forward. Feel free throughout the sessions to add questions in the Q&A, and we'll monitor that. And also, if the chat mode becomes enabled, and we'll talk, we'll mention, I'll have a look kind of as we go. And let's move forward. Just worth kind of saying now. So if you aren't yet in the Discord, now is an amazing time to join. We already have, I think it's 1,200 plus, 1,200 plus community members that all joined pretty recently. This is a new term, LLMOps. It's kind of, some would claim it doesn't even exist yet. And we're going to start having a lot of interesting things. So the event is part of it. We have a mechanism for how to announce open source products and also commercial products. We're going to have beta programs for startup when they want to offer with some sort of discount in exchange for feedback, all sorts of programs, and showing different types of consultants and having a mapping of them. So we're going to try to do things that are useful for anyone that's dealing with LLMs and how to get them into production. And the first thing we released is some sort of mapping of the company's products in the space, which is a start, and is going to become, of course, more details. There are going to be more companies. Some of these companies are going to have more tools, but we're starting already to see that around the backbone of the community that's building the first use cases of putting, taking the leap of faith and putting LLMs into their actual business flow and their actual, it's actually taking something out of what otherwise would be something that's not based on LLMs. So we're starting to see patterns that are forming, and that's a lot of what we're going to be talking about today, is kind of delve into some of those patterns and see what we're actually, what does the stack look like when you're trying to use it for something real. So a bit about the agenda, you'll see it a lot more kind of when Rafael and Puneet kind of take more over, but we're going to be talking about a few different areas, and you can have a look here, but I won't dive in yet, because you're going to get a lot of this kind of moving forward. A bit about the speakers, since it's always harder for them to present themselves. So Rafael and Puneet work together, and it sounds like they have a very good friendship going on between them, aside from the professional work they're doing. Rafael has a track record of 15 years, spanning software engineering, AI solution architecture, and so forth. And now he's been working with companies recently on a lot of generative AI. So this has to do with what they, had a lot of knowledge in that has to do with MLOps. And now it kind of evolved together with the needs of the customers, or together with the needs of the companies they're working with. Puneet is in a similar position, but first of all, different geography. And he has a lot of experience bringing data and ML solutions from the whiteboard all the way to production, starting from recommender systems to price optimizations, and also now dealing a lot with LLMs. So it's a pleasure to have both of you working together and getting a lot of different experience. I think what's really special about this setting, and why I thought it was, both myself and our team, I thought it would be interesting for a first talk, is just because they meet a lot of actual customers. There are a lot of people talking about it. There are some very interesting open source and school projects. There are also actual real companies that are using them, but I think they have a very high concentration of those real companies that are working with a real use case. So before we dive in, if you or any of your colleagues want to speak at a future event, the link is right over here. For those of you that for some reason are listening without seeing the video, then you can find a way to apply also if you just go to LLMOps.Space. So we're setting it up. Again, we don't have any mechanism which is structured. We don't know exactly what the events are going to look like, 8 or 10 events away from now, but reach out, apply, and we'll be in touch on that. So without further ado, we can move over to Rafael.
Amazing. Thanks for the intro, Philip. And yeah, super happy to be here, especially given that it's the first edition of this awesome event. I'm going to share my slides. You guys know the drill. So today, me and my colleague Puneet, we're going to talk about what's involved when building an LLM ops stack, and also try to showcase a bit about what is an LLM ops stack, right? What is LLM ops more generally, right? So, Philip, thanks for giving our intro. I think just one thing I would like to add, we are both special solutions architects at Databricks. This means that we are constantly talking to customers. Most customers nowadays are super excited about generative AI and LLMs, how to make the as much business value as possible out of this. We're going to share our learnings, our recommendations, and our advice when we talk to these customers, right? So there are many different common use cases when it comes to generative AI and LLMs. What is the top most common use case, at least in our experience? A lot of customers, a lot of companies, almost everyone wants to create conversational experiences for customers, right? And then you link to different topics like digitalization, making customer service more streamlined, making your experience stand out as a company, right? So this looks like pretty fun and pretty much fun and games. In theory, how do we go around putting this into practice, right? So basically what we're trying to answer here, the first challenge, where do I start? So as Philip showed previously, by the way, super nice map of all the players in the industry right now. You can imagine that is a super new trend, but we already have many players creating some super nice stuff in LLMs and to help LLMs move into production, right? On the other hand, it can feel a bit overwhelming, right? So where and when do we use each of these tools? Okay, so what we're going to discuss right now is what we see as the natural point of view when approaching LLMs, right? So the first step is you select one of these foundational models. By foundational model here, we can be anything from ChatGPT to Llama to MPT and so many others. The first natural step is prompt engineering. If you're not familiar with prompt engineering, don't worry, we're going to cover a little bit about what is entailed by that. But in a high level basis, prompt engineering basically learning how to talk to your model. What is the best way to ask questions? What is the best way to parse the outputs and the responses and so on. The next natural step is evaluation. We want to find out, okay, is there any better way to ask these questions? Are these questions good enough? Are these questions, can these answers still be improved? And part of the evaluation is basically reaching the conclusion. Are the results that we achieved after doing prompt engineering, are they good enough for my use case? Then naturally, there are two possible outcomes here, right? So first outcome is, okay, I've experimented with prompt engineering and a particular LLM. Results are great. Let's deploy these to production. This is already another discipline, right? Is the work done when we reach that step? Unfortunately, or fortunately not. So there are many ways to deploy to production. At least 3 different strategies you have: canary deployments, blue and green, A/B testing, and so on, right? As a result, there are other aspects that are related to these step in the journey, right? You want to have a minimum degree of observability. You want to monitor data drift, you want to monitor model drift, and so on. But let's go back to the other possible outcome after we evaluated prompt engineering experiments. It could be that prompt engineering by itself is not good enough. In this case, we need to ask ourselves another question. Do we have more data? And how much data do we have, right? If we have lots of data, and we can also get into detail about what's considered lots of data, but if we have lots of data and the data quality is good, we can just go on. If it's an open source model, we can fine tune it. Some of the proprietary models, they can also be fine tuned. For example, ChatGPT and GPT 3.5 and 4. The next natural step is fine tuning. Does it end there? No. We need to evaluate, make sure that the results that we got after fine tuning, they're good. But it could also be that after fine-tuning, we want to go with a hybrid approach. After fine-tuning, we want to experiment another time with prompt engineering and find out what is the best way to ask questions. The other possible outcome or the other possible scenario here, if you don't have enough data, you can also go with another approach, which we're gonna detail as we go through the slides as well, which is called retrieval augmented generation, which has its pros and cons. That basically entails another piece of the stack, which we're also gonna talk about. But here we're basically giving additional context to our model without having to fine tune it, right? So let's say that you have an internal knowledge base of hundreds or even thousands of documents, and you want to plug that into your LLM. Retrieval augmented generation is the way to do it. And again, people might ask the question, sometimes our customers ask the question, is our work finished here? And I think by now you must have guessed that it's not really the case, right? You need to perform evaluation. One important thing here is to understand what kind of parameter combinations are performing best, what kind of retrieval augmented generation configurations are performing best, and whatnot. So there's another evaluation round. And another possibility here, in the same way that you can have a hybrid approach where you first fine-tune and then you do prompt engineering, here is the same thing. Once you have retrieval augmented generation in place, it could be that you're pretty much good to go and you can also already go to production, but it could also be that you need to spend a bit more time with prompt engineering. And there is the last way, the more comprehensive approach, which is you fine-tuned your model, you notice that your prompt engineering experiments were still not good. You can combine your fine-tuned model with prompt engineering plus retrieval augmented generation, right? When it comes to the stack, what exactly are we talking about, right? So starting with prompt engineering. So what you can see on the left-hand side are some common tools in terms of open source and proprietary frameworks that you can use to help you with prompt engineering and chaining. When it comes to evaluation, there is a different group of tools, for example, MLFlow, weights and biases, and so on. Deep checks, Arise, Fiddler, also for not only evaluation, but also tracking your predictions and your generative AI application. Retrieval augmented generation is a topic in itself, but here we also have a distinct set of tools that can be part of your stack. I think as a more general comment, you have both open source and proprietary alternatives here. Which one is best will depend a lot on your particular level of maturity. It has a lot to do with the eternal buy versus build discussion, maybe topic for a more extensive discussion, but I think you get the idea here, right? And with fine-tuning is the same, right? So you have platforms, for example, Mosaic ML and Cerebras, which are completely dedicated when you want to fine-tune an existing open source model, or even if you want to pre-train a model from scratch. Last but not least,
just 1 second. I'll stop in here with a couple of questions you got. I'm sure we'll have more because this is sort of the area that's like very deep in the subject we're talking about. So one question from Ankush Singhal. I hope I got that right. What are some tools for prompt evaluation? So I think some of what you touched here already was really, but I'll let you answer.
Yeah, sure. So for instance, it's a good question. For MLFlow is famous for being one of the de facto standards for experiment tracking, but also MLFlow with version 2.7, there are some features which are specifically related to prompt evaluation. So no matter if you are running an open source model or if you are running if you are using ChatGPT or Anthropic, there are specific features for prompt evaluation and comparing across different models as well. And MLFlow is just an example, all right? You have a plethora of tools here, for example. Deep checks is also one of them, and I know that Philip has some nice stuff cooking, so I would definitely stay tuned around deep checks here.
Yeah, it was a bit of a bummer when we were preparing them. We had some interesting things we could show together, but we didn't publicly release yet what we're doing for LLM evaluation. But it'll come, I hope, not in that long.
Yeah. So now it's good because we have a teaser. Everyone is going to be curious, right?
Yeah.
Yeah. So that these are the most known tools, at least personally for me right now. But of course, the field is growing super fast. There are new tools popping up each and every day. Here we are bringing some of the examples of what you can already use, and it's already considered production grade.
Okay, so a couple of other questions.
Mm-hmm.
All right, so the first question that we had is whether what are the different environments, if I got this right, by it's a combined first and last name, so I'll just guess it's Satya. Whether there are any environments that are set like dev, user testing, prod. So how do we set that up? You know, especially in the sense of LLMOps, I could also give some sense about that, but let's let you kind of go with that for a bit.
Yeah, no, of course. I think this will depend. The answer depends on two things. One, the maturity level that you have and the existing practices that you have as a software or a cloud tech organization. And it also depends if you are just doing prompt engineering or fine tuning, right? And why is that, especially specifically about the latter? If you are doing fine tuning, open source models, there are so many different ways that things can go wrong, right? So you will want to test many different things. For instance, your data pipelines, they can break. Your model fine-tuning workloads, they can break. So in this case, the more comprehensive is your pipeline, the more of these disciplines and these steps that we described here, if you're executing all of them, I would say my personal advice is you will want to have a better segregation in terms of environment, right? A better way to guarantee that your production setup doesn't break whenever someone is testing a data pipeline or a fine-tuning pipeline and so on. So it can go anywhere from something really simple like production only environment, which is quite common, especially in startups. Also exploration environment versus exploitation, or non-production versus production. And also some more traditional cases where you really need to have zero downtime. Most of the customers that I've talked to, they have these kind of characteristic. They will go for a really DTAP environment: development, UAT, acceptance, and production.
Okay, so we're getting a lot of more questions. I think we'll start to. I don't want to leave questions unanswered, but I think we'll increase the pace of it. So I'll take a few quick ones of them. So a question of what is the difference between MLOps and LLMOps? There are a lot of different definitions, and I don't think there's that much written yet about the term LLMOps. I'll just say I think LLMOps is a subset of MLOps when the model that you're working with is LLMs. In a lot of cases, this means less focus on training and more on some other things. I'll just say in a word, what is considered an LLM? That's also open for debate. Some call LLM only anything generative, and some will say that transformers that are, you know, the standard of what you see in Hugging Face, that's also an LLM. So I see a duality there, but in general, I'll say the mainstream, when we say LLMOps, the mainstream is an application that you're taking, you know, either GPT 3.5 for some cases 3, or a similar model and putting it as part of the pipeline. I think that's the mainstream of what most people think of, and we'll let the, you know, some other people kind of, you know, take that into account as we move on. And then can the same set of tools be used for MLOps and LLMOps? Basically, I'll say, wait 1 second. Basically, I'll say the answer in general is no, but a lot of vendors that had an MLOps tool, that had MLOps tools, added LLMOps capabilities. So in a lot of cases, it sounds like it's the same thing, where really there are some adaptations. I think that's fair to say. Yeah, so then there are some other things. I'll try to answer some of them kind of live, but you know, I don't think we'll be able to answer everything, and it's exciting for me to see how many attendees we have and how many questions we have. But you know, then the price to pay is a bit less attention for each question, and sorry about that. But you can continue.
Yeah, I think there is one that we will definitely cover when Puneet starts talking about the retrieval augmented generation, which is the one from the left. Talk more about deciding between fine-tuning and RAG. Super interesting question. Do you think you can take this one when you go through RAG, Puneet?
Yeah,
or maybe
absolutely.
or right now? It's up to you.
Yeah, I mean, see, at the end of the day, there are two aspects, right? There's always a cost associated with moving from fine tuning or just thinking about retrieval augmented generation, right? In term, if I had complexity and if I had time to market as a scale metric, prompt engineering sits at the bottom because it's very quick, very easy to iterate through. A little more complex is retrieval augmented generation because there are a couple of technologies that come into play, which we will discuss. Don't worry about that. And then comes fine tuning. Now, within fine tuning, the idea is you need a lot of really good compute based on the type of model that you're trying to select to do the fine tuning exercise. You need to understand the basics of Torch and PyTorch and understand the distribution frameworks such as Deep Speed and FSDP. And then you need to chain all of those together. Right now, with fine tuning, there are certain caveats that if you do not set the correct parameters, you can end up with what is known as dead gradients or dead vanishing gradient points. So fine tuning at this point is reserved for practitioners who are really comfortable with deep learning, the concepts, and about distributed frameworks. Whereas when it comes to retrieval augmented generation, that is something that even beginners or analysts can sort of pick up because there's no complex training and tuning involved. There are a couple of technologies that need to be stitched together, but we can walk you through what those are and what decision points you need to make.
Awesome. I'm just conscious of time, so I'll move to the next steps. Next step. So here, just as a bottom line, we've seen which steps are usually involved when approaching LLMs and what possible paths you will have to walk depending on your use case and your data and your setup. Let's recap a bit on the use case example that we were talking about, right? So lots of customers, they want to enable conversational interfaces. How do we start? So we talked about prompt engineering in the previous slide. What is exactly prompt engineering for folks who are not familiar, want to learn more about it, right? First of all, a disclaimer, there are many papers being published every week about prompt engineering and LLMs in general. We're gonna bring what we think are the most common approaches, right, when approaching prompt engineering. So as an example, when we're talking about the banking domain, we have an approach which is called zero-shot learning. Here, we're not providing a lot of context to an LLM. We just take a pre-trained LLM, we try to ask a question to it. So for the case of banking domain, a really simple example is you have a customer, you deploy this LLM as a customer service chatbot, and the question is, someone comes to you and say, okay, I lost my bank card. What should I do? Right? The response in this case can be, for instance, this question is related to the topic bank cards. So if we stop for a second and look at this answer, this is not necessarily wrong, but some other follow-up questions. Is this what I expected to get from this chatbot as a bank? It could be that I have a more fine-grained set of intents or a more hierarchical taxonomy, let's put it like that, right? So if you're looking at a really simple solution or a really simple use case, it could be that this answer is right. But at the same time, the model is a bit naive. So it was fine-tuned with a really general data set in an unsupervised fashion. Is doing pretty much the best it can to answer this question. And if you look at this, it is correct. Maybe not ideal for our use case. If you want to take these even further, while still resourcing to prompt engineering, we can use something which is called few-shot learning. And few-shot learning, we're basically trying to give some examples to our model. So in our prompt, we will have two parts now. The first part is the prompt template, which is going to be included in each and every question to our model. So for our example, we're talking about this part here. So we say, okay, the following Q&A pair is an example of a dialogue. So the question is, I can't find my bank card, which is similar to our previous question. And we're telling the model that in this case, the right answer is lost bank card. It's not really bank cards because bank cards is too general for our use case. Let's just work with this assumption. And then finally, we include the actual question, which is, I lost my bank card. So the idea of few-shot learning is we provide one or more examples to show the LLM what we exactly expect for these examples. And more often than not, the LLM understands that based on these examples, this is the right thing to say when we get a similar question to the examples we provided. So this is basically few short learning, but we still have, as you might imagine, we still have challenges, right? It could be that few short learning is not enough. It could be that if I want to provide lots of examples as part of our prompt, our LLM context window size is finite, which means there's only a limited amount of context that we can provide to the model. What do we do when this context size is not enough? On the other hand, knowledge is infinite. Knowledge is generated fast. The world moves fast. How do we deal with these challenges? So I'm going to hand it over to Puneet, and he's going to talk about how to tackle these challenges.
Perfect. Should I start sharing my screen, Raf, or are you okay to move the slides?
Yeah, I just have one more comment that's kind of coming from the questions from a few different areas. So the question of how do you test, how do you evaluate, you know, what are the different phases towards getting to production? I'll just say what I see as standard. First thing you do, just take a prompt, plug it in, like, you know, do something very, very quick and dirty, kind of see with your own eyes. Second phase is to set up a test. You know, some companies call it test set. We like to call it deep check. So we like to call it the golden set, something that represents your main use case. Get it to work on that. Have a benchmark for what evaluation looks like. Next phase is what we call the beta phase. Means you bring friendly users that either try to use it or just try to use it regularly, and then you get their feedback, implement their feedback, maybe make some adaptations to the golden set and so forth. Next phase is production, and of course, production can be on you know, part of the population and so forth. So it just came up in a few different ways that, you know, there are in a few different mechanisms. There are different toolings for this. There are different approaches, but I think what I mentioned now is kind of the mainstream. Rafael and Puneet, to kind of correct me if you think if you see something
absolutely else. Raf, if you can release the screen, I just want to quickly share the screen as well.
Oh yeah,
perfect. Thank you.
Go for it.
Let me know, guys, if you can start seeing my screen. Can you see my screen, guys?
Yes.
Yes.
Perfect. On that topic, very quickly, because I know evaluation is a key concept. Just plugging back to what Raf said, that here is where, you know, tools like MLFlow, weights and biases and others become fairly important. Similar to what Philip you mentioned, have your golden data set or your test data set where you have a bunch of questions that have already been answered, peer reviewed internally. And then you have certain evaluation frameworks from where you can start comparing outputs of different LLMs or different prompt engineering structures. This can then help you really isolate cases where your LLM is not performing, do the reverse engineering exercise where you can then focus on those questions, get them correctly automated, and then you can start sort of flowing all the experiments together and doing a cross by cross multiplication. The other aspect for a more automated solution would be you could do something like a cosine similarity or a ruse score, where you have the correct answer, you have the answer generated by an LLM. Just do a cosine similarity and aggregate those and see which one has the highest cosine similarity to get sort of like a proxy metric out. So again, open research field, but within MLflow, lots of options, lots of opportunities for you to evaluate, explore, and expand. Very quickly now, just interest in the time, moving on to the next bit. As Raf mentioned, in our use case, we have a finite context window. How can we leverage what the LLM has already learned, but add contextual information as and when required? So in the case of the banking license, let's say if you lose a bank card, there are 6 or 7 steps that you need to follow. They are hidden in an FAQ section in the website, but you want your LLM to understand that the context is already being talked about, pass that FAQ into the LLM's context window and ask it to generate an answer. Well, that is what RAG or retrieval augmented generation is all about. How can you give the LLM the correct context from a myriad of different documents so that it can efficiently answer a question? So that is the fine line when it comes to fine tuning versus generic prompt engineering. And we're going to sort of talk about what are the steps involved in that. So let's take another example, right? Given that we at Databricks are a Spark and AI company, we get a lot of generic questions about Spark. One of them being, what is Spark Connect? and I want to now create a support box similar to the banking bot that Raf mentioned. So let's talk about what are the technologies and tools that we would want to use to sort of build that out. The first thing that we would want to do is we want to curate all of our documents in a fashion that if I ask a question, there is a system which can quickly give me the top and relevant documents. It could be 5 or 10. The idea over here is not to build a system which can automatically curate the correct documents, just give a ballpark or a ball shot of that. This is where two technologies are very effective, which is embedding language models and vector databases. Talking about embedding models at a very high level, what they do is they convert our textual representation into vectors, right? So going back to our math degree, if everything is a vector, you can quickly do analysis to say, right, what are the 10 vector points that are closest to my particular vector data point? And if now I take this analogy back into language models, if I ask a question, what is Spark Connect? And if all of my documents are actually created as vectors, I can quickly do a math search to say, right, these 10 documents are actually talking about Spark Connect. Let me grab those in. So this is where vector databases come in. I saw a couple of questions where people were talking about, well, OpenReach is generally used for classification, is generally used for product recommendation, for log aggregation. Well, the idea is that they are really good tools to do similarity search. So we use their vector, their optimized similarity search engines or the vector searches. We use the open LLMs to convert text into vectors. So you would need an open LLM, and the choice you have are you have about 20-30,000 different open embedding models in Hugging Face. Hugging Face actually has an open leaderboard champion where you can actually see what are the top performing embedding models based on a specific set of categories. And then you again have the proprietary models such as Anthropic, Cohere, as well as ChatGPT. When it comes to vector databases, you have again an plethora of options, proprietary as well as open source. Chroma, Fies are the open source versions, Pinecone, Elastic are the proprietary versions. Within Databricks, we also have a managed service on top of Elastic/OpenReach services as well. So now what happens is, if you look at the chronology, I ask a question, the question gets converted into a vector, the vector hits my vector database, gets the top n correct questions. I need a mechanism to chain all of these things together. So I need a mechanism which can, if I ask a question, hit my vector database, get the top n answers and pass it to an LLM. This is where we have chaining tools that Raf mentioned, alluded to. The most popular ones as of now are LangChain and Copit, but there are myriad of other options coming up. NVIDIA has come up with their own NVIDIA Nemo. In terms of maturity, we see a lot of clients going towards LangChain because it just has a raw support and it has been around since the inception of ChatGPT. So if you're starting out, go with LangChain, but you're free to explore other tools and techniques as well. So the LangChain is going to hit the embedding model, get the vector, get the closest vector, and then it is going to pass it to an instruction-led LLM. So that LLM can be a very simple API. It could be ChatGPT 3.5 for Anthropic Cohere from a proprietary setup, or it could be any of the open LLM models. Personally, me and Raf have played around with MPT and Llama 2. And for a lot of the retrieval use cases, they can reach comparative performance to ChatGPT 3.5 whilst cutting the entire end-to-end TCO cost up to 1/10. Again, on very specific data sets, we've seen them actually perform really brilliantly. And from an end-to-end platform perspective, which can give you an orchestrator, a vector engine, embedding model, both for LLMs as well as for embedding orchestration, you have a myriad of options. AWS is missing, but AWS has its own utilities as well. Azure, Databricks, NVIDIA, all of them have their own entire offerings as well. But if I have to give you a TLDR slide, it would be that when you're thinking about retrieval augmented use cases and setups, there are 4 technologies that you need to be absolutely certain of. The first one is a ETL platform where you can take unstructured data and put it into a vector search. Second would be an embedding model, again, proprietary or open source. Third would be a vector engine, again, proprietary open source. And the fourth aspect would be an LLM, again, proprietary or open source. So right now we live in this golden age where all the options that we talked about have a proprietary offering as well as an open source offering. So depending upon the scale, size, and complexity that you have to actually build out the use case, you could actually go with either of those options. So that's essentially like RAG in a visual summary.
Okay, great. So where are we with more content? Because we have quite a few questions that kind of piled up.
I think, yeah, I'm good. I think I'm happy to, we can start taking questions rather than go through content.
So I warned Rafael and Puneet that if we have questions from the audience, and if there weren't, then I would have questions of my own. So that indeed is and was the case. Just say one question we got a few times if there'll be a recording after the event, if it'll be available. So yes, that is one of the plans. So hopefully it'll be up, and we'll enable it through our Discord. Just saying now, I'll share the link again, but the idea is to have all the resources in one place. So we have the website of LLMOps.Space, and then we have the Discord, which will also contain pretty much all the information except messier, but also more interactive. So that's one question that came up again. I'll give the next question. So there were quite a few questions about this, about the specifics of doing, of looking into the RAG use case and so forth. So let's talk about one that came up again: the nuances of when to fine tune and when to just do prompt engineering. So I know you kind of mentioned that, but I'll just say my take on it, and then feel free, both of you, to kind of jump in and add it. Don't fine tune at all. Like when you have 50 customers and they're not satisfied with what's exactly happening, this and that, then consider fine tuning. I mean, I know I'm being drastic. I just don't. I see a lot of companies playing with it. I don't see it ending up becoming really important. I think it's not the right focus at the beginning. I may be wrong. I'm sure there are use cases where I'm completely wrong, and definitely if you have a something very weird about the language, but I'd love to hear your take on that. Sorry for being so blunt, but I think that it's better to have an interesting topic than an interesting talk then. So that's overly correct.
I think, Philip, I'm in the same boat as you. So the other dimension I like to add over here is the cost complexity. So when you're doing retrieval augmented generation and you want to switch to fine tuning, the cost impact is 10x, because you would have to now have specialized hardware, go through technical development, trial and error for a couple of weeks, with no guarantee that the end product is going to be any better than the RAG model. So it all boils down to the fact that in your initial attempts to do prompt engineering, how bad were the results? As you mentioned, if there are only 5 questions out of 500 that your bot got wrong, well, that's not a clear-cut use case for you to go to fine-tuning. But if it's something like you got 250 questions wrong out of 500, absolutely, you have no other option but to go fine-tune or abandon the project. That's my 2 cents on it.
But this is only after a lot of work in the prompt engineering space, right?
Oh, yeah,
first
absolutely.
You spend, I don't know, months improving the prompt engineering. Only if you get to a dead end, I would look into. That's my intuition.
And the other aspect I would like to add over here is how niche is your use case that you're trying to develop. An example would be if you're trying to create, let's say, a bot to answer formulas that are used in chemical engineering process. Well, dollars to no nuts, maybe the LLM that you're using is not going to be able to answer that. So that's another clear-cut use case where you might have to use RAG and then try to stitch it up in a particular fashion, that you have so much technical jargons that a RAG bot might not be able to suffice on top of it. But if it's something like a generic bot that's more customer service enabled and customer friendly, well, my experience, RAG has worked 9 out of 10 times.
Amazing. Okay, so I think we have time for one last question, and then we'll finish up. I know there are a lot of questions that are not answered, but we answered 39 questions, right? We answered 39. There are another 22 open. I'm pretty happy with the pace, but yeah. Okay, so next question. So there's a question about how does the few shot learning work? Do we reduce the probability distribution space by giving some examples?
Yes.
Ra-
So that's exactly the reasoning behind it, right? So we gave an example actually about providing an example of question and answer, but there is some place between zero shot and few shot where you basically tell the model, okay, this question is about blah blah blah, right? Which is already a way to reduce that probability space, right? And this is actually quite useful in some applications where you want to reduce the chances of hallucination, right? You want to avoid, for example, asking a question about banking and the model outputting a question about retail or energy or even worse things, right? So that's definitely the idea.
Amazing. I just want to say, I think we saw a lot of the questions, a lot of the attention, and also a lot of the talk on the RAG use case, which is indeed very common. There are some other use cases that I'm starting to see quite a lot, and I just want to say the stack is very interesting even for them. It might include less components, but it's just as important. So, so like seeing summarization of complex text like legal and medical, and then we have quite a lot of things where you have an LLM is part of the pipeline, but you end up creating a table or a JSON, and which in some ways is kind of like classification, we know, but it just has some phases that are different. Then there's, dealing with code, reading code, writing code. There are so many different, creating graphs, out of financial data. There are so many use cases that are real. That's not just like for a cool demo. I can't wait to see kind of what my experience as a user going through all these different great brands and websites and products will look like in a year or something. But in the meantime, I think what we just kind of showed here is really just the beginning. Each single logo you saw here in the slide is probably going to improve their offering a lot, modify it, change it, and also the use cases will just have more and more requirements because the requirements, as the use case matures, then the requirements also mature. So I think we're going to wrap it up, even though of course there's always more information, but we're going to aim to have the events a bit shorter and with a bit less extensive rather than have folks get used to listening to part of it. So I'll just remind again, I sent in the chat the link to join the Discord. So LLMOps.Space/Discord. Feel free to apply for speaking at future events or to send over some of your colleagues. And we're going to have the next event with Qdrant in about 10 days. So stay tuned and you know where to find us. All three of us are available on LinkedIn and I believe also on the Discord server. So feel free to reach out with any follow-up, whether it's about something specific you didn't agree with, something you want to learn more about, or something that we left kind of unexplained or with encrypted language and so forth. In any case, so pleasure to have you all here. Thank you so much for joining, and see you next time.